Hello, in this video we'll be working through Unit 6 homework problems 15 through 19. These problems I'll deal with Riemann and trapezoidal sums. Number 15, given below is a table of function values for h of x. Approximate each of the following definite integrals using the indicated Riemann or trapezoidal sum using the indicated subintervals of equal length. For part A, we want to approximate the integral from -3 to 1, so that defines our interval. Goes from -3 to +1, using two subintervals and a left-hand Riemann sum. So we're going to go from -3 to -1, and then from -1 to +1. That'll give us two subintervals, and we're going to use a left-hand Riemann sum. So to get the height of each rectangle, we use the left edge. So I'm going to use 5 as the height of my first rectangle, and the width will be the distance between -3 and -1, which is 2. So the width there is 2, and the height is 5, so the area of that rectangle is 10. My next rectangle goes from -1 to 1, so the width is 2, and for the height I'm going to use the left edge, and that has a value of 2. 2 times 2 is 4. So the total area would be 10 plus 4, or 14. So we did 2 times 5 plus 2 times 2 to get 14. Part B, we want to approximate the integral from -3 to 9 using three subintervals and a right-hand Riemann sum from -3 to 9. So we'll go from -3 to 1, and then from 1 to 5, and then from 5 to 9. That gives us three subintervals. And let's find the width for each one of these intervals. From -3 to 1, that has a width of 4. From 1 to 5 also has a width of 4. And from 5 to 9 also has a width of 4. To get the height of my rectangles, this is a right-hand Riemann sum, so I'm using the right edge of each rectangle. So -3 for my first rectangle, -2 for my second, and 11 for my third. So the first rectangle has an area of 4 times -3, or -12. My second rectangle has an area 4 times -2, or -8. And my third rectangle has an area 4 times 11, or 44. And if we're doing this without a calculator, we can factor out this 4 here, leaving -3 minus 2 plus 11. So -3 minus 2 is -5, plus 11 is 6, and 4 times 6 is 24. Part C, we're going to approximate the integral from -3 to 9 using three subintervals and a midpoint Riemann sum. So we'll go from -3 to 1, from 1 to 5, and from 5 to 9. So this is a similar setup as our last problem, so I know these widths are each 4. But this time the height of the rectangle is determined by the midpoint. So the 2, the -7, and the 6. So the first rectangle has an area of 8. That's 4 times 2. And then the second rectangle, 4 times -7 is -28. And the third rectangle, 4 times 6 is 24. And if I'm doing this without a calculator, it's pretty easy to just use our sums that we have up here. I would add the -28 and the 24 and get -4, and then add the 8 and get 4. Or here I can factor out a 4, leaving 2 minus 7 plus 6. So 2 minus 7, -5 plus 6 is 1, times 4 is 4. Part D, we want to approximate the integral from -3 to 3 using three subintervals and a trapezoidal sum. From -3 to 3. So my intervals are going to go from -3 to -1, make a trapezoid there. And then from -1 to 1, we'll make a trapezoid there. And then from 1 to 3, we'll make a trapezoid there. So the widths of my trapezoid from -3 to -1, that's a width of 2. And from -1 to 1, that's a width of 2. And from 1 to 3, that's a width of 2. Now to get the area of the trapezoid, I have to take these widths and multiply by the average base. So I'm averaging these two values. 5 plus 2 is 7. So I have 7 divided by 2, and then I'm going to multiply it by the 2, and that's just going to give me 7. For my next trapezoid, I'm going to average these, nope, not those, these two. So 2 plus negative 3 is negative 1. So negative 1/2 multiplied by the 2 just gives me negative 1 for the area of that trapezoid. And then my next trapezoid, I average these two values. So negative 3 minus 7 is negative 10, divided by 2 is negative 5. And then I multiply by that width. So negative 10 is my area there. And 7 minus 1 is 6, minus 10 is negative 4. So my total area approximation would be negative 4. Let's write out how I did that. So I did 5 plus 2 over 2, and then multiplied that by 2. For my second trapezoid, I did 2 minus 3 over 2, and then multiplied that by 2. And for my last trapezoid, I did negative 3 minus 7 over 2, and multiplied that by 2. So these 2's are canceling out. It's going to make our computation a little easier. 5 plus 2 is 7. 2 minus 3 is negative 1. And then negative 3 minus 7 is negative 10, giving us an answer of negative 4. Part E, we're going to approximate the integral from negative 3 to 9 using 6 subintervals and a trapezoidal sum. Negative 3 to 9, see, 1, 2, 3, 4, 5, 6, okay? So we'll go from negative 3 to negative 1, then from negative 1 to 1, and then from 1 to 3, from 3 to 5, from 5 to 7, and then from 7 to 9. So my width for each one of these intervals, subintervals, is 2. And we're going to multiply that width by the average base. So I'm going to, for my first trapezoid, I'm going to average the 5 and the 2, and then multiply it by that width. So I get 7. For my next trapezoid, I'm going to average 2 and negative 3 and multiply by the width, and that's just going to give me negative 1 for the area of that trapezoid. Then for the next one, I'm averaging the negative 3 and negative 7, multiply by the width, and that's going to give me negative 10. And the next one, we're averaging negative 7 and negative 2, and then multiplying by the width, that's going to give me negative 9. The next one, we're averaging negative 2 and 6, multiply by the width, that gives me 4. And my last one, we're averaging 6 and 11, multiplying by the width, and that one is going to give me 17. So my area, we have 7 minus 1 minus 10 minus 9 plus 4 plus 17. So let's see, I've got minus 1 minus 9 is minus 10 is minus 20. And then 7 and 4 is 11, and plus 17. So the 11 and the 17 is 28. So I have negative 20 and positive 28, and that's going to give me an answer of 8. Number 16, approximate the integral from 0 to pi of 2x sine x dx using 4 subintervals of equal length and a right-hand Riemann sum. I prefer to do Riemann sums using a table, so I'm going to make a table. I have the function that'll help me get my y values, and to get my x values, I just have to take my interval from 0 to pi and divide it into 4 equal subintervals. So my table is going to start at 0. It's going to end at pi. That's a total distance of pi, and if I divide that into 4, each part has a length of pi over 4. So 0 plus pi over 4 is pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4, which reduces to pi over 2. Pi over 2 plus pi over 4 is 3 pi over 4. And then if I add pi over 4 again, I get 4 pi over 4, which reduces to pi. So those are my x values, and then I'm going to call these my f of x values down here. So when x is 0, 2 times 0 times the sine of 0 is just 0. 2 times pi over 4 times the sine of pi over 4. Well, the sine of pi over 4 is 1 over root 2. I might have to do some side work over here. So I have 2 times pi over 4, which is pi over 2, times the sine of pi over 4, which is 1 over root 2. So I have pi over 2 root 2. Okay, then at pi over 2, I have 2 times pi over 2, which is just pi, times the sine of pi over 2, which is 1, so that's just going to be pi. At 3 pi over 4, I have 2 times 3 pi over 4, which is 3 pi over 2, times the sine of 3 pi over 4. 3 pi over 4 is in quadrant 2, so it's positive. It's 1 over root 2. So this is 3 pi over 2 root 2. And 2 times pi times the sine of pi is just 0. So I have my table values. And I want to find a right-hand Riemann sum using 4 subintervals of equal length. So I'm going to have a rectangle going from 0 to pi over 4 to pi over 2, pi over 2 to 3 pi over 4, and then 3 pi over 4 to pi. The length of each, or the width of each one of these subintervals is pi over 4. That's how I found those values, was by adding pi over 4 each time. Pi over 4. And the height of my rectangle, since I'm doing a right-hand Riemann sum, is determined by the right side of the triangle. So my first rectangle has an area, pi over 4 times pi over 2 root 2. So pi squared over 8 root 2. Pi squared over 8 root 2. My next rectangle has an area of pi over 4 times, and then this right side, pi over 4 times pi. So that's just pi squared over 4. My third rectangle would be pi over 4 times, and then I go to the right side, so times 3 pi over 2 root 2. So that's 3 pi squared over 8 root 2. And then my last rectangle will be pi over 4 times, and then again the right-hand side, 0. So that one's easy. That just has a height of 0. Now thankfully this is a calculator active problem, so I don't have to worry too much about trying to get a common denominator and adding all these things together. Okay, so I need pi squared divided by 8 root 2. Plus pi squared over 4 plus 3 pi squared over 8 root 2 and just plus 0. So 5.957. Number 17, approximate the integral from -1 to 10 of e squared x squared dx using 4 subintervals of equal length and a trapezoidal sum. Our interval goes from -1 to 10. That means the total width of my interval is 11. And I have to take that distance of 11 and divide it into 4 subintervals of equal length. So 11 divided by 4 is 2.75. That means the width of each interval is 2.75. So good thing we have a calculator for this question. I'm going to start at -1. And then my next interval has to be 2.75 away from that. So I'm going to store the 2 points. Actually, I don't have to do that. Let's do -1, hit enter, and then I'm going to add 2.75, and I can just hit enter, enter. I can just keep hitting enter to get these until I get to the one I need. So -1, and then 1.75, 4.5, 7.25, and 10. Those are my x values. And now for my y values, let's see if we can do this a little more quickly using y1. So I want e squared. Let me try that again. E squared, there we go. E squared times x squared. And I'm going to go in and put my table on ask. So I go into the table setup and I change the independent to ask. And then I go into my table and I can ask for the y value at -1. So we have 7.389. And then the y value at 1.75 is 22.629. At 4.5, I get 149.63. And if I need to see more decimal places, I can put my cursor over that value. So it's 149.628, actually. It's 0.628. 7.25. And let's highlight that value. So here it's 388.387. And at 10, we get 738.906. Okay, we are using 4 subintervals and we're doing a trapezoidal sum. Trapezoidal sum. So my width for each one of these intervals is 2.75. And I need to multiply that by the average base. So I can type this all out. It's going to take a while. I have to add these two numbers, divide by 2, and then multiply by the 2.75. And if we need to show our work, if we need to show our setup, the long way is going to be 2.75 times 7.389 plus 22.629 over 2. That's just my first trapezoid, and then I do that for each one of my trapezoids. But notice that each one of my trapezoids, the width is 2.75. So second trapezoid, these are the two bases. So 22.629 plus 149.628 over 2. Okay, plus then my next trapezoid also has a width of 2.75. So each of these terms has a factor of 2.75 in it. So we can save ourselves a little bit of trouble by factoring that out. But I'm going to show the whole setup here so we can see the pattern. My next two bases, 149.628 plus 388.387 over 2. And I've got one more. I'm going to have to put it down here. 2.75 times, so my last trapezoid has these two bases, 388.387 plus 738.906 over 2 equals, that would be a lot of numbers to type in there. We may just have to do it anyway, but I think I can probably figure a way to do this on my calculator a little more efficiently than me having to type all of these numbers. It's a lot of button presses there. But I do want to point out that we've got 4 terms here that we're adding together. And in each one, I am multiplying by 2.75. So we can factor out that 2.75. And let me also point out that in each one of these terms, I'm dividing by 2, which is the same as multiplying by 1/2. So I can factor that out as well. So if I take out the 2.75 and I take out the 1/2, it's going to look like this. And then, let me point out something else here. 7.389, that was my leftmost edge. I've got 22.629 in my calculation twice. It gets counted once in the first trapezoid, the right side, and then also in the second trapezoid, the left side. So that gets counted twice. My 149.628 gets counted twice. My 388.387 gets counted twice. The only ones that don't get counted twice are the very first edge of the first trapezoid and the very last edge of the last trapezoid. All the inner edges get used twice, once for the trapezoid on the left and once for the trapezoid on the right. So I can save myself some button presses if I say, oh, I know this is just 7.389 plus 22.629 plus 22.629. I can just say that's 2 times 22.629 plus 2 times 149.628 plus 2 times 388.387 plus the 738.906 only occurs once, like so. So that makes it a little bit easier to compute on the calculator. Okay, let's just do it. 2.75 divided by 2 times 7.389 plus 2 times 22.629 plus 2 times 149.628 plus 2 times 388.387 plus 738.906. For a final answer of 2,567.927. Number 18, given the table below, approximate the integral from -2 to 9 of p of x dx using 3 subintervals and a midpoint Riemann sum. From -2 to 9, so the whole table, using 3 subintervals. So we'll go from -2 to 1, from 1 to 5, and from 5 to 9. Let's get the width of our intervals. From -2 to 1, that's a width of 3. From 1 to 5, that's a width of 4. From 5 to 9, that's a width of 4. We're using a midpoint Riemann sum. So we use the middle values to get our heights. So we want 3 times 8 plus 4 times -4 plus 4 times 2. So the first area, 24, the next area, -16, and the last area, 8. Or 16. And number 19, we want to approximate the integral from -2 to 9 of p of x dx using 6 subintervals and a trapezoidal sum. 6 subintervals, so 1, 2, 3, 4, 5, 6. Trapezoidal sum. Let's get our, trapezoidal sum. Let me draw that differently. I like to make them look like trapezoids when I'm doing a trapezoidal sum. Okay, so our widths from -2 to 0, that width is 2. From 0 to 1 is 1. From 1 to 3 is 2. From 3 to 5 is 2. From 5 to 8 is 3. And from 8 to 9 is 1. we have to multiply those values by the average bases. So 5 and 8 is 13. 13 over 2, that's my average base, times 2. Gives me an area there of 13. Plus, and then I take my average base here, so I'm adding 8 and 2, that's 10. So 10 over 2 times the width, which is 1, and that area is 5. For my next trapezoid, my bases are 2 and negative 4. So 2 plus negative 4 is negative 2 divided by 2, multiply it by the width. So that's negative 2. My next trapezoid has bases negative 4 and negative 1. That's negative 5 over 2 is the average base, times the width, which is 2. So that one has an area of negative 5. My next one is the negative 1 plus 2, which is 1, over 2. That's my average base. Multiply it by the width, 3. So get 3 over 2. And then my last trapezoid, I'm going to take the average base here. So 2 plus 5 is 7 over 2 times the width, 1. So plus 7 over 2. Okay, now we can add the 3 over 2 and the 7 over 2, make 10 over 2, which is 5. And the 5 minus 5 is 0, so that's convenient. And now I just have 13 plus 5 is 18, minus 2 is 16.